I'm going to continue on looking at JavaScript. Now, I appreciate many of you, if not all of you, have worked your way through the 2 JavaScript labs, in particular the second one. First one was pretty straightforward, I think. But I'm going to complete this set of slides anyway, just in case some of you may have struggled a little bit with the second lab. Can I just confirm everybody can hear me?
Yeah.
Right.
Yep.
So we'll just pick up the story. Roughly where we left off was looking at higher order functions. And a higher order function is a function that takes another function as a parameter. We refer to that parameter as a callback. So we have the higher order function and we have the callback function. And the general idea is that the higher order function invokes the callback somewhere within its code. Now I just want to check some. Okay. So we'll see a lot of this going on throughout this module, and just by means of a kind of a case study, I decided I would look at the array data structure, which has a number of methods really that are higher order functions. I'm kind of mixing the term method and function because they are really the same thing. They boil down to the same thing when you look at any kind of pre-ES6 JavaScript code. So don't let that confuse you. So there's a whole bunch of these higher order function methods that come with the array data structure. And I'm just looking at some of them just by way of kind of a case study. It's roughly where we left off the last day. So I skip over all that because we know what the API is all about. Can people mute their microphones, please? Otherwise, you're just interrupting everybody else. I explained this the last day. And so I suppose Postman, I'm not sure if I mentioned about Postman or not. Postman, it comes in 2 forms. You can either get it as a plugin to the Chrome browser or as a standalone app. I actually won't be using it, but in the second half of this module, Frank will be using it quite a bit, I think. It's a nice tool for essentially communicating with an API, try and find out what is the API returning to you. So I'm just including it there for as a reference, I suppose. Right, so I have a bunch of samples, and again, I appreciate now that people are kind of ahead of me in a sense in the labs, but just bear with me anyway, and I go through it fairly quickly. So here's my little project with an index.html. I start my go live server, usual story. And open up my developer tools. And we know what each of these samples does. Each of them communicates with an API, the random user API, takes the data and just processes it in some way. If we look at the first example, which is this one here. So, right, so we're referring to this file here. And if we look at it, and again, we've all kind of seen this now in the labs, but just to break it down a little bit. So fetch is a function that's built into all browsers, and what fetch does is it makes a HTTP GET request to whatever URL you've given it. Now, of course, that response that comes back will come back sometime in the future, which is significant, but we can just kind of ignore that complication. The way it works is when the response comes back, which is sometime in the future, it's not immediate, but when it does come back, the runtime will then call this method passing it the response. And what the then method does is it also takes a callback as an argument, and it invokes the callback. Now, inside in the callback, sorry, it's a little bit clumsy the way I parse this. So the response comes back from the API. Now that response may be fragmented. And so the response needs to be reassembled, number one. And number two, the body of the response will be in a format called JSON, which is very close to JavaScript, but it's not JavaScript. So that JSON structure that comes back needs to be converted into a JavaScript representation. And a JavaScript representation of a JSON structure will be a little network of JavaScript objects. By network, I mean a kind of a hierarchy. So the reassembling of the response that comes back from the API and the conversion of that to JavaScript response, that's all done by this bit of this function call here. Eventually, the response that comes back from the API is complete, it's reassembled and it's converted. And only when all of that is done, it's only then that the runtime will call the second then method. And the then method takes, again, a callback as a response. The then method will invoke its own callback. And in this case, we can interpret this parameter that is passed to the callback, as the name kind of suggests. This parameter is going to contain the body of the response that came back from the API, and it will be in the form of a JavaScript data structure. So we can process it straight away. Now, if you're working with an API for the first time and you're not too sure what is the structure of the response body that comes back, then the very first thing you should do is stick a console.log in here of response body. And if I just quickly do that. And straight away, go to your developer tools and make sure you understand that structure. So in my case, am I looking at the right one? I'm not, sorry. My index.html, I didn't save the index.html. So this here is the JavaScript representation of the body of the response that came back from the API. And as I said, you know, if you're working with the API for the first time, you need to expand that and you need to make sure that you actually understand the structure of the data. Because if you're going to start interrogating this object, obviously you need to know its structure. So the first thing we can see is that if we look very closely, we can see that what is returned is an object, a JavaScript object. It may not always be an object. It could be an array in some cases. So that's the starting point. You need to establish which it is. And within that JavaScript object, we would eventually work out that it's inside in the results key of that JavaScript object. That's where my actual data is. There are some other properties as well that we're not interested in. We're not interested in the info one, and we're not interested in this one. I know this third one here is a standard property that all JavaScript objects have, even the JavaScript objects that we create ourselves. They have some properties by default, and one of them is called the prototype property. But anyway, that's not of interest to us. I'm not sure where the info one comes from. Does the fetch introduce that somehow? But the key one anyway is results. So the results key within my object contains the data that I'm actually looking for. And it won't always be, the key won't always be called results, maybe called something else. So you do need to be clear on the structure of the data that comes back before you ever start processing it. And in this simple little script, we're not doing anything interesting with the data. We are just iterating over it, but we're iterating. We know that response body dot results, because I've just shown it to you. We know that expression, this expression here, evaluates to an array in this particular case. Okay, won't always be. And so because it is an array, we can call the for each method on that array. And the for each really is an alternative to writing a for loop. And I explained the last day, I think I got that far as to how the for each works. The for each calls the callback that you pass to it, which is here. It invokes that callback once for each element in the array. And you can do whatever you want to inside in the body of the callback. Just pause for a second now, in case there are any questions. No, all good.
Yeah, can you just repeat this bit of the for each? I just came now.
The way the for each works, just 1 second now, sorry. The way the for each works is, so this is an array of objects. It's an array, really, I suppose it doesn't have to be an array of objects. This is an array. What the for each method does is it invokes the callback that you give to it once for each element in the array. So the first time this callback is executed, the parameter there is going to contain the first object in my array. The second time the callback is invoked, this parameter is going to have the second element in the array, and so on. So we are executing this callback function once for each element in the array. And for each invocation of the callback will receive as a parameter a reference to the element in the array that's being processed. The callback actually can take up to 3 arguments. If you're not using the rest of them, you can leave them out. But there are 2 other arguments. One is called, or you can call it anything you want to. I call it INX. The EX, what did I do? Strictly speaking, the callback can take up to 3 arguments. The first one is always going to be a reference to the current element in the array that's being processed. This parameter is going to be the index position of that element. This parameter is going to be the full array. In other words, this is actually going to be referring to the same array as what that is referring to. But if you're not using these 2, you can leave them out. Okay.
Yeah.
Right. So moving on. I'm going to close that and undo that. So that's the for each higher order function associated with the array type. The next higher order function that we're going to look at is the filter function associated with the array. It also takes the callback. What filter does, just go back to for each first. We don't really care what the for each returns. You can see, you saw from my code there, I wasn't assigning what for each returned to anything because it doesn't really return anything useful to us. It's different though with filter. What filter does is it returns back to you a completely new array, where that new array has a subset of the elements of the source array that's being processed. And what elements are contained in the new array depends on the callback that you pass to filter. The callback that you pass to filter, it has to return a Boolean true or false. If it returns a Boolean true, then the current element that's being processed is added to the new array. If it returns false, it's omitted from the new array. So in a sense, the callback determines which elements in the source array should be put into the output or results array that filter returns. So that's kind of what I'm saying there. The source array is unchanged. So we would classify filter as being a pure function, doesn't make any changes to the source array. And so we have an example of it, again, using the random user as our case study. So I don't need to explain the start of it. Where we pick up the story is from here on. And response body is going to be the exact same now. Response body is going to have my array of user profiles. I'm just console.logging them just for our own understanding. And you see this is the way we could have, so sorry, what's the objective here for start? The objective is to pick out all female profiles in the array of profiles. So I want to create a new array that contains just females from the array, the full array that was returned back to me by the random user. So this is the way I could do it using old style coding, right? I could create an empty array, which is what I'm doing here. And then I have my standard for loop that iterates over that array. And I have my condition test to check to see is the current profile equal to female. If it is, then I push it or add it to my array. Okay, that's the way we would do it if we didn't know anything about the filter higher order function. This is how we do it though, using the filter. So I call my filter on my source array, and again, the filter takes a callback. And okay, I'm just doing a console.log inside in the callback. Remember now, this callback is invoked for every element in the array. But the critical line in the callback is this bit here. So I'm doing some sort of condition test, and that's what I'm returning. The callback that you pass to the filter must return a Boolean result. So you can see what it's doing is checking to see is the current profile that's being processed, does it have this property? And if that evaluates to true, then whatever element is currently being processed, that element or profile is going to be added to that array there. That's the output array. Any questions about that? No, and I console.log that just to prove to myself that it worked. Just another example here. The objective is to find all males who are under 40. Same story. Here is my callback that I'm passing to filter. And because it only has a single line of code, I'm using the arrow function shorthand notation. So my arrow function begins here. This is the callback, as I said. All right, this is the callback. And I just have a condition test. I don't need the return keyword. I don't need the curly braces, etc., etc. But if that is confusing you, then you just go return. And don't forget the closing curly brace, and we're good to go.
Would it be good practice to try to use return in general, or not really?
I think as a beginner, if you don't mind me referring to you as a beginner, I think you're better off writing it this way to get it working. And once you're happy that it's working, then you can start getting fancy and say, well, if it's only got one line of code and that's its return statement, I wonder, am I able to convert this into the shorthand form? As an after. Don't try and write the shorthand form first, because there are a few gotchas. One of the gotchas is, if I go back to the shorthand form, if you put a semicolon there, you're going to get an error. So you don't put, even though when I started talking about JavaScript, I said the semicolon is an optional, but there are places where you cannot use it. From my memory, this is probably the only place where if you do include it, you're actually going to get an actual runtime error. Ordinarily, you won't. And the reason this is confusing the runtime is you're saying this is the end of the statement here, but what statement is being ended? It doesn't know what statement you're actually ending. So that's the only kind of gotcha. Don't put the colon there and then it'll be fine. There are no other cases where using the semicolon will throw an error, or omitting it will throw an error. That's the only one that I've ever come across. So as I said, start off by writing it longhand, and then once you get comfortable, start changing it to shorthand, get it to work, and then you'll eventually lapse into using the shorthand notation probably all the time. I still use longhand notation every now and again. I just forget about the shorthand. Okay, that's filter. Let's move on to map. The map takes your source array and it creates a new array as its result, but there's a one-to-one in terms of the number of entries in the new array versus the source array. If you think about the word mapping, mapping means taking one thing and kind of converting it into something else. So the structure of the entries in the new array are determined by the callback. And whatever the callback returns, that return value is put into the new array. Okay, so if we look at the example. Just going to undo any changes I made to that. So in this case, my objective I'm saying here is to create an array that just contains each person's name and email. The original array of profiles that I have has lots of information about each user, but I want to create a new array that just has for each user just their email and their name. So I'm mapping from one to the other. Again, I'm showing you this is how we could do it if we just wanted to use your standard for loop, but map does it in a much more succinct way. So here's my map, and again, it takes a callback. And as I said, all of these callbacks, the arguments are the same to the callback. It's a reference to the current entry that's being processed, with the caveat that you also have the option of adding on. If you want to use the index position of where that is, then you can get at it by adding a second parameter to the callback. It doesn't arise in our case though. And you can see, again, there's only a single line of code in this callback. I'm just constructing a new object. So this is the actual structure of the objects that are going to be in my output array. We can actually just see it in the browser because I'm console.logging it. Yeah, so you can see each entry in the output array just has an email and a name as its properties. If you want to make this into a shorthand form, there's another little gotcha here actually. So if I get rid of return and I get rid of that, and I also get rid of, let's see now, so that closes off that, so I don't need that any longer. That kind of looks right now. No, it's not. I don't need. There's the semicolon that's going to cause us problems. Now, I anticipate there's going to be an error still with this, and the error is just highlighting another little gotcha, but let's see whether it arises. So I'll save that. And as I expected, I am getting a runtime exception. So this is the second gotcha, and it is if you've got an arrow function and the arrow function is written in shorthand form, and what it is effectively returning is an object, which it is in this case. There's my object. You've got to wrap the object in parentheses. Save, and now it's happy again. Now I said a while ago the semicolon was the only gotcha. I'd forgotten about this one actually. I'm pretty sure those two are the only gotchas with the shorthand form of the arrow. But as I said earlier on, better off writing it in longhand form really initially. Any questions on, well, let's not worry about the shorthand versus the longhand version of the arrow. I don't want to get into that really, but just in terms of map. Here's another example. What I want, the objective here is to create an array that just contains the ages of the various users. So here's my callback. And, you know, I'm just returning profile.dob.age. And when I console.log that array, it's just going to look like this. Okay, so it's just an array of, sorry, is that the right one? No, it's this one. Yeah, so there are the ages. But you can see there, like each of my arrays has 10 entries in them. So map always produces an array of the same size as the source array. I requested 10 user profiles from the random user API. That's map. And finally, and this is kind of the odd one out, there's the reduce higher order function. Now the one-liner for what does reduce? So reduce, it takes a callback, as they all do, but it does take a second argument, which none of the others do. Now what does reduce do? I'm saying here that reduce takes the source array, or sorry, it reduces the source array to a single accumulator value. And we know what a kind of accumulation means. So it gives this notion that reduce iterates over the source array and it produces a single accumulator value result. That wasn't the case now with filter and with map. Both of those produced a new array, but in the case of reduce, it produces a single accumulator value as its overall result. So this here, right, because this is what I'm assigning some array that reduced to. This here is going to be a single value of some sort. And the value then depends on what the callback does. The purpose of the callback, essentially, in this case, is to calculate the accumulator value, but it calculates it incrementally. As you process each entries in the source array one by one, it starts to build up the accumulator value one by one. So the callback, it computes the updated accumulator value based on the current entry that it's processing. The first time the callback is invoked, it's going to be invoked for the first entry in the source array. You need to tell the callback what is the initial value of the accumulator. And that's what this second argument's purpose is. This has to be set to the initial value of your accumulator. And that initial value is going to be passed to the first invocation of my callback, and it's going to be assigned to the first argument. So ACC there is going to be the current running accumulator value. And of course, the first time we call the callback, this is really going to be equal to whatever the initial value is. Element is the current element in the array that's being processed. Index is the position of that element. Array is the full array. Let's not worry about these two. So there's a difference now in the structure of the callback versus the filter and map callbacks. In the filter and map callbacks, the first argument that we passed to the callback was a reference to the array element. But it's not in the case of reduce. The first parameter is the current running total of your accumulator. And inside in the body then of the callback that you pass to reduce, it's in there. What it will do is presumably it will take the current running value of the accumulator and it will update it. And critically, the callback has to return that updated value. And the returned updated value is now going to be set as the new accumulator value for the next invocation of the callback. It's hard to talk these things. So I'm saying here that the return is the updated accumulator. Let's look at an example. So my first illustration of it is the simplest one I could come up with. So my objective is to calculate the average age of all of the user profiles that were returned to me by the random user API. And again, this is how you do it with a for loop, but we're not interested in that. So here's my array of profiles. Here's my reduce. Here's my callback. And here's the initial value. So what the reduce is actually going to do for me is it's going to calculate the total of all of the ages. And then I just do an average calculation down here. Is that what I do? Yeah, like I take the length of my profiles and I use that to divide into the total ages. So my reduce here, its purpose is to accumulate the total ages of all of my users. So the initial value sensibly would be 0. That means that I keep making that mistake actually. I keep turning it in the wrong position. So here's my callback. It's called once for every element in my array. The first time it's called, total is going to be 0 because that's what I set it to. This is going to point to the user profile. And inside in the body of it, you can see what I'm doing is I'm computing total plus the person's age, and that's what I'm returning. Which means that the second time my callback is invoked, total is now going to be equal to the age of the first user. Profile is going to refer to the second user. And again, I'm taking that person's age and I'm adding it to total and returning it. So this now is going to be equal to the age of my first two users added together. Callback is invoked again, so total now has the ages of my first two users, and I'm invoking the callback for the third time. So that's going to refer to the third user, and so on and so forth. Is that okay?
Yep.
Okay.
Yep.
And then I just compute the average down here. That's a simple example, simplest example of when you use the reducer. But in the slides, I said that, so the reducer kind of computes an accumulator value, a single accumulator value. But accumulator there has a much broader can have a much broader meaning than our kind of general understanding of what an accumulator is. The general understanding of what we have as to what an accumulator is as I'm using it here. But if we look at the second illustration, so my objective here is to find the youngest person in the array of profiles. Okay, so that's not your traditional kind of accumulator idea, but the reducer will actually help me in finding the youngest profile. And I've commented it out, but you obviously can bring it back in. So if I bring it in, in this case, so my objective is to find the youngest. In this case, the initial value from my accumulator, I'm going to set it at 100 because nobody, I'm just saying anyway, everybody is going to be younger than 100. Okay, if I set it to 0, it's not going to work. If I set it to 0, then I'm not going to find anybody that's younger than 0. So I'm not actually going to, I don't know what it's going to return back to me in that case. So I want to find the youngest, sorry, what do I want to find? Oh yeah, I just want to find the youngest age, sorry. I don't want to find who it is. I just want to know what is the youngest age. So if I initialize it to 0, then every time I run this, it's always going to be 0. So that's no good. So I set it to 100. And then after that, in terms of my callback, what am I doing? So again, this is always going to have, min is always going to have the youngest age that I have found so far as I work my way through the array. Profile is always going to refer to the current user being processed. And within the body of the callback, you can see what I'm doing. I'm just checking to see, is the current person that's being processed, is their age less than the current minimum using my ternary operator? If it is, then assign that person's age to this running variable or this local variable. Otherwise, assign it min and return this value. You can stick a console.log in there to help you work out what's going on in that reducer. The very last example that I'm showing you is much more involved. The objective is I essentially want to generate, essentially this is going to be my accumulator in this case. I want to know how many people were aged between 25 or under, how many were between 25 and 50, how many were in this age bracket, and how many were in this age bracket. So it is an accumulator in that sense. I'm accumulating these numbers here. How I do it then, you can look through that yourselves. I'm not going to walk through it, but it's pretty involved. And if you're comfortable, you can obviously re-enable this code here and see if you can follow how it actually works for yourselves. I'm not going to talk my way through it. I don't see you ever getting an example really in this module anyway, as involved in that. In fact, you may not even get a chance to use reduce. You'll certainly be using map a lot. You'll be using filter a little bit. But I won't be using reduce, I think, from here on in, but you may get to use it in your own assignments. So that's the reduce or higher order function associated with the array type. And you can read through the summary yourself. Right, for me anyway, that's the end of our review of JavaScript. There'll be other little bits and pieces of the language syntax, mainly kind of ES6 plus stuff that we will use as we work our way through our discussion on React. And when we come across that syntax, then I'll just have one slide explaining the syntax to you so that you understand how it's actually being used within our React code. Okay. Just before I move away from that section, are there any remaining questions? You may have specific ones related to the examples. Probably the labs are the best place to discuss those, but I'll give you an opportunity anyway.